Welcome back. Today we are going to learn a very funny thing. It involves lots of zeros. Okay, before we start the class, let's pray to zero. Okay, close your eyes, fold your hands and say along with me. Om Poornamadaha Poornamidam Poornaat Mudachyate Poornasya Poornamaadaaya Poornamevavashishyate. Slowly open your eyes. Suppose you have a subtraction problem like this. Okay? Look at this problem. Don't solve this problem. Okay? Don't try to solve. Just look at this problem and ask your body if this is a difficult problem or an easy problem. Pause the video. Your body would say, this must be a very easy problem because it involves lots of zeros, right? We can start solving this problem from left to right. First we have a 1 minus, there is nothing, 0 here is a 1. Before we put down the 1, we see this guy needs help. Okay, we give 1 away and this is gone. It's like this 0 becomes a 10. Okay, 10 minus 8 is a 2. Okay, before we put down a 2, we look at this guy. Okay, this guy needs a help, so we put a 1. Okay, and we gave away a 1 to this guy, so this becomes a 10. So 10 minus 6 is a 4. Before we put down a 4, we see this poor guy needs help, so we give away a 1 and we put down a 3. And finally 10 minus 4 is a 6. So these kind of problems are very often we encounter. So for example, you have a $100 note or a rupee note. Suppose we have in Japan, we have a 10,000 yen note. Suppose we are buying something, we give a 10,000 yen note and we should know how much change we get. So these kind of problems are very important. But usually these kind of problems take some time to do. But there is a very beautiful way to solve these kind of problems. The golden rule is all from 9, last from 10. Okay? You got it? What it means? In this kind of problems where we are actually subtracting a number from lots of zeros, in this part of the problem, what you need to do is you simply have to subtract these digits from 9 and the last digit from 10. Oh, is it true? Okay, what we did here is, look at the answer. 9 minus 8 is a 1. 9 minus 6 is a 3. And because we reached the end of the problem, so it's 10 minus 4 is a 6. As simple as this. Suppose you have a problem like this. 10,000 minus 2,345. The answer comes right away. The golden rule is all from 9 and last from 10. Now you do the problem along with me. Okay, first 9 minus 2 is a 7. 9 minus 3 is a 6. 9 minus 4 is a 5. And 10 minus 5 is a 5. Wow! Now we have 600 minus 77. The first digit is not a 1. It's a 6. Now what we should do? Just pause the video and think about it. We have to use the golden rule. Yes, we will use the golden rule for this part of the question. And how about here? What happens to the 6? We simply give 1 away from 6. So 6 becomes a 5. Okay, and here we apply the golden rule. As simple as that. So first we have all from 9. That means 9 minus 7 here is a 2. And we reach to the end. Now we subtract 7. From a 10, we have a 3. As simple as this. Now pause the video and try to solve these problems by yourself. Here are the answers for you. Did you get them right? You can see the first digit 4 simply becomes a 3 and we apply the golden rule here. Here 5 becomes a 4 and we apply the golden rule here. As simple as this. Okay, we have another variation here. Okay, before I tell you, can you say the answer? Okay, you can pause the video. Okay, how do we do this? So we apply the golden rule to this part. And how about here? It's 8 minus 4. Do we put a 4 here? No, okay. From 4 we give 1 away to these guys. So here we put a 3 and we apply the golden rule here. So 9 minus 2, 7. 9 minus 2, 7. And we arrived at the end. So 10 minus 2 is a 8. As simple as this. Now pause the video and try to solve these huge subtraction problems by yourself using the golden rule. Here are the answers for you. Did you get them right? Yes, you can see here, 2 minus 1 is a 1, but we give away this 1, so it's gone. So we only need to apply the golden rule here. And here we have zeros here. Okay, so we do 3 minus 0 is a 3, but we give away 1, so we write down a 2. And here we have 0, so we apply the golden rule and we get the answer. As simple as this. Suppose you went to US, okay, you gave a $10 note to buy something worth $7.53. How do you solve this problem? How much change you should get? Okay, so we can use the same way. So $10, okay, we put a decimal point here and then you can add as many zeros as you want. And then we subtract 7.53. How do we do this? As simple as this. We apply the golden rule here. So this 1 is gone. So we have all from 9, last from 10. So 9 minus 7 is a 2. So we put a decimal point here. 9 minus 5 is a 4. And 10 minus 3 is a 7. $2.47. Now, can you do these problems just by looking at them? You don't need to write you can write down the problem and do everything in vertical fashion. No. Pause the video and see if you can just tell the answer. Okay, here is how I will do. I guess you would do the same. First, $10 minus $6 is a $4. Okay, we know somebody needs help. So instead of 4, we put down a 3. And then what you have to do is, you have to apply all from 9, last from 10 to this part. So this is 9 minus 5 is a 4. 10 minus 1 is a 9. Okay, now same here. 20 minus 3 is a 17. Okay, but we put down a 16 because we give 1 away and apply the golden rule here. 9 minus 1 8. 10 minus 8 is a 2. As simple as this. Before we finish, I want to tell you something interesting called number splitting, where we can actually separate a big problem into small parts and you can handle them very easily. Okay, whether it is addition, subtractions, multiplications or divisions. This number splitting can make our life much easier. Okay, we will see a couple of addition problems. Suppose you have a problem here. It's a 4-digit addition problem. We have to split this problem into two small addition problems. Okay, when you split, the rule is there should be no carry from one part to other. Okay, how can you split this? Can we split here? 5 plus 8 is a 13. Okay, carry is jumping. No, we cannot split here. How about here? We can split because we can see there is no carry coming from this part to this part. And now you simply do the addition and put down the answer. Okay, and here also, where can we split this question? Can we split here? No, because 8 plus 6 is a 14 and a carry is going to come. How about here? Oh, there is no carry here. Okay, we can split this into two parts and simply write out the answer. Pause the video and do this yourself. Here are the answers for you. Did you get them right? We can do this number splitting for subtractions as well. Okay, for example, we have a 4-digit subtraction. Okay, how can we split this? So, can we split here into two parts? 4 minus 6. Oh my God, there is a lending and borrowing things coming into picture here. Okay, we don't want to split here. How about here? Oh, this is so easy. We can do this subtraction and this subtraction separately and we write down the answer. As simple as this. Same here. Okay, now pause the video and do the subtractions using number splitting by yourself. Here are the answers for you. Did you get them right? We can use number splitting for multiplication problems as well. Okay, suppose we have 352 times 2. Where can we split this problem? Can we split here? If we split here, there should be no carry from this part to this part. 2 times 2 is a 4. Oh, okay, there is no carry. Oh, that's very easy to do. We can split, first multiply 35 times 2 and then 2 times 2. You can simply put down the answer. 35 times 2 means 35, double for 35 is a 70. 2 times 2 is a 4. As simple as this. Okay, now look here where we can split this problem. Can we split here? 7 times 4 is a 28. Okay, so there is a carry here jumping to the left. Okay, how about here? Can we do this? Okay, this is simply a 2 digits. 04 times 7 is 28. Okay, answer is also 2 digits. That means there is no carry here. Okay, we can split the problem here. And 7 times 6 is 42. Okay, 7 times 4 is a 28. So 2 digits produce 2 digits. There is no carry. Okay, that's why we are able to split this problem here. Oh wow, big multiplication problems. But still, we can actually now split this multiplication problem into smaller parts. Actually, we can split this multiplication into 3 parts where there are no carries. Can you guess? And here, we can split again into 3 parts. So, pause the video and try to do this yourself. Okay, here we go. So, we cannot split the number here because 2 times 5 is a 10, there is a carry. But here, we can split. Okay, nice. So, here, Okay, there is a carry. 2 times 7 is a 14. How about here? There is no carry. Okay, and that's it. You can multiply these 3 with 2 and put down the answer. So 12 times 2 is a 24. 17 times 2, 34. 45 times 2, double of 45 is a 90. As simple as this. And how about here? Can we split here? Yes, there is no carry here. Can we split here? 5 times 3 is a 15. Okay, we can't. How about here? Oh yeah, we can split here. So, and then we have 3 separate multiplication problems. We simply combine them to get the final answer. So 5 times 3 is a 15. 13 times 5 is a 65. 5 times 1 is a 5. As simple as this. Same with division problems. I have not yet taught you division in Vedic way, so you can skip this section, or if you already know a little bit of division, you can go ahead with me. Okay, so suppose we have a division problem, 432 divided by 2. So here you can split this division problem into 2 parts. Can we split here? 2 divided by 2 we can do. 43 is not divisible by 2, so we cannot split here. Okay, how about here? Can we split here? Okay, yeah, this 32 is divisible by 2 and 4 is also divisible by 2. Okay, very simple. Now 4 divided by 2 is a 2. 32 divided by 2 is a 16. As simple as this. How about here? Where can you split this problem? Can you split here? No, because this is an odd number. We can't divide by 2. So, but here we can split very easily. You can try this yourself. Okay, and then here, where you can split. Can you split here? Okay, 6 is divisible by 3. Is 126 divisible by 3? Yes. Okay, so you can split here. In fact, you can split this into 3 parts, right? So 12 divided by 3 is a 4. 6 divided by 3 is a 2. 6 divided by 3 is a 2. As simple as this. Did you get the answer for this? The answer for this, you can do 34 divided by 2 is a 17. 56 divided by 2, half of 56 is a 28. As simple as this. Now pause the video and look at these problems, how to solve using number splitting. Okay, don't solve them yet because these two are a little bit tricky. Okay, here we can see because we are dividing with a 6, 12 is divisible by 6, so we can simply split the problem here like this. Okay, now what is the answer? 6 divided by 6 is a 1. 12 divided by 6 is a 2. Can we put down a 2 here? No, actually we have to make it a 02 because there are 2 digits here in the problem. So we have to put a 2 digits here. Okay, so that's why we added a 0 here before 2 and we made it a 02. Okay, and then here similarly you can see you can split this problem into 2 division problems. Okay, first 28 divided by 7 is a 4. You can put a 4 or 04 because it is at the beginning of the problem. You can simply put a 4. 04, it doesn't matter. But here 49 divided by 7 is a 7. Okay, here we have to put a 2-digit answer. So instead of 7, we put down a 07. Okay, and here you see how can you split this problem? Actually, you can split this problem into 3 parts. Okay, where to split? You got it right. Here and here you can split. 24 divided by 3 is 8. 45 divided by 3 is a 15. 3 divided by 3 is a 1. That's the answer. You can do some homework problems given in the video description below. That's all for today. Thank you.